Welcome to class Olusegun Mass Clinic. Today we want to talk about salt. Salts are quantities which are not capable of being expressed in rational number. It is also called a rational number it's also called irrational numbers like root 2, root 3, root 7, and etc. We also have what we call the rules of salt. Rules of salts. What are the rules? Number 1, if you have something like root AB, can be written as root A times root B, which is the same thing as root A times B. Another law that we have is when you say root A plus root B is the same thing as root B plus root A. We also have another law. If you have root A over B, can be written as root A over root B. So that is just how to. Another one we have the law 4. Root A plus root B can never be equal to root A plus B. Another law, we have a root A squared B can be written as root A squared times root B, which is A root B. So that is the laws of salt. The law still continues, which reaches what we call a similar salt. What we call a similar salt. Another one which is number 6. Number 6. Similar salt. Now, in similar salt, if you have 1 root A plus root A, the same thing as 2 root A, because they were 2, so it will be 2 root A plus. Another way where the similar salt occurs, when you have root B plus root B, is the same thing as 2 root B. It's continuing to the rules number 7, which we're able to say that root A times root A should give you root A squared, which is the same thing as A. Under rules, we call it a conjugate salt. Conjugate salt, which we have root A plus root B is a conjugate of root A minus root B. The last but not the least under these rules is what we call rationalization. Rationalizations. The first one is if you have a plus root b over a minus root b, it can be written as a plus root b over a minus root b times. You change the signs in the denominator, which is a plus root b all over a plus root b. If you're able to divide this and this, you still discover it's 1. But in rationalization, what we do is that we change the signs of the denominator. So it will make it easy. Another one is a over root b can be written as a over root b times root b over root b. So these are the laws of Surds. This will make us to have an example. We have an example. Let's have example 1. Example 1, we have evaluate the following sort. If you are to evaluate Roman figure 1, we have root 125. The Roman figure 2 is root 18. Solution. If you are to evaluate this for the Roman figure 1, which is root 125, recall that root 125 can be written as 25 times 5, which we are able to have explained from the law that which have the multiplication signs. Let's check where it is. Maybe the first page. You're able to see that root a squared b can be root a squared times root b. So which is so we are applying the law 5 to that questions. So which is, and it will give you root 25 times root 5, which will be 5 times root 5. Answer will be 5 root 5. In the Roman figure 2 questions, which is root 18, by the time you find the factors of 18, it will be root 9 times 2, which is root 9 times root 2. We are still obeying the third law, which will give us 3 times root 2, which is also 3 root 2. We continue the example. We have evaluated this. We still have another example. Example 2. He said evaluate the following sorts. So which is A 4 root 2, B 2 root 7, C 3 root 7. Go to the next page. Now, if you are to evaluate such, you said 4, like this, you are changing it to singular surd. You take this one inside, it will be 4 times 4 times 2. So which is root 16 times 2, which is equal to root 32. So it's as if you call it a singular surd. The B part of that question said 2 root 7. As I've said earlier, you scale this back, 2 times 2 times 7, which is equal to root 4 times 7, which will give you the root 28. I want you to practicalize this in the comment section. You should give me the answer. Change this one to singular surd. So you send it to me in the comment section. So it go further. That is, we have another example on similar surd. Another example in similar surd. Let's have the example. You said evaluate the following surd. What A, we have to deal about 2. Say 4 root 2 plus 3 root 2 plus root 2. If you are to consider all these surds, you discover that they both have same thing, root 2, root 2. Therefore, this is, if root 2 is common, or let's say 4 root 2, so it means the 4 of this, the 3 of this, and 1 of this. So this is 4 times 4 plus 3, making 7, plus 1, because 1 is here, making 8 root 2. We have the B part. The B part says root 3 plus 7 root 3 plus 5 root 3. You see that root 3, root 3, root 3. So this is 1 is also here too. 7 plus 5 making 13 root 3. So that's because they were a similar sort. So there is a way they also expand the questions in a way that you reason better. So let's solve the C part. Let's see how the C part B said root 125 plus 4 root 5 plus root 20. So if you are to solve this, you discover that root 125 can be written as 25 times 5 plus 4 root 5 plus root 4 times 5. And root 25 here, as I've said from the law, to give you root 25 times root 5 plus 4 root 5 plus root 4 times root 5. Therefore, this will give you 5 root 5 plus 4 root 5 plus this one will give you 2 root 5. So it is similar because they all have same root 5. So 5 plus 4 making 9. 9 plus 2 making 11 root 5. So that is so far so good. We will have able to explain the rules of the surds and to some certain parts a very reasonable example. So we also want to explain how we multiply surds, which relating to conjugate surds. Let's have an example that's related to surd. Let's say example on conjugate surds, or we can also call multiplication of surd. Said expand the following bracket. Expand the following 1. He said root 5 plus root 2 onto root 5 minus root 2. If you're able to study, you discover that this one is a conjugate of this, and this is a conjugate of this because the sign changes. So you now start expansion. He said root 5 bracket root 5 minus root 2 plus root 2. So the root 2 will now expand root 5 minus root 2. So which is root 5 times root 5 will give you root 25 minus root 10 plus root 10 minus this will give you root 4. So if you have to see, this will give you 5, this will cancel this, which will give you 2. The total answer will be 3. So that is how conjugate being expanded, because it will change because the sign inside has changed. So another example, so you solve the third example for me in the comment section. You will reply, you tell me what you are able to see. That will be your classwork. Root 3 plus root 2 onto root 3 minus root 2. The same thing applicable from what we have done the early time. Root 3 will expand to root 3 minus root 2 plus root 2 onto root 3 minus root 2. So root 3 times root 3 will give you root 9 minus root 6. This will give you plus root 6 minus root 4. As early, this will cancel this, making root 9 minus root 4, which is 3 minus 2, which is 1. So I want you to solve this for me in comment section. 1 plus root 2 onto 1 minus root 2. So you solve this for me in comment section. So it now remains the rationalization, which we are going to talk in modulus 2. So I will want you to go back to the reverse the page. So in modulus 2 of the surd, we talks about the rationalization. Once again, don't forget to subscribe to this channel so you can be able to see anytime I release video, be able to say the topic. So the channel name in the YouTube at Olusegun Mass Clinics. So the same thing Facebook and TikTok, we have the same name. So thanks for the class.